Hello. We often get asked what the isoproportional attributes in GeoTeric can tell us about the data. So I'm going to look at that in this video clip. What I've got here is the isoproportional slicing tool, and I've split my data between the two bounding horizons, the green one at the top and the bottom, and I've split it into 5 iso horizons, each one more or less covering a single reflector. We've got 6 attributes that you can see on the right hand side that we're going to calculate over these 6 slices. So if we look at these results, what you see on the right hand side is the result for each of the different iso slices. So if I look at iso slice 1, what we're seeing at each point on this map in this case is a maximum positive amplitude within these 2 red lines. So for that whole section of data, the maximum positive amplitude on each trace is returned in this map view. So we can see everything is orange, it's all fairly uniform in terms of its amplitude. If I look at the maximum negative amplitude, so this is the maximum trough response, you can see that in most of the area is quite quiet, it's very low. That's because we don't actually have much of a trough response down there in most places. But in the top and in the bottom, there's a very strong response. And if I move my slice over so that we can view that section there, we can see that this response corresponds to this thin bed that is appearing over in this northern section. So by looking at the maximum negative amplitude, we've been able to identify where we've got this thin event that is separating that previous peak. If we look at the peak trough amplitude, this is the maximum distance between the peak and the trough that we've previously identified. So obviously the higher the amplitude, or if you've got both peak and trough in your interval of interest, then you'll get a higher value there. So again, you can see up in this northern section is where we get the highest values, the greatest difference between the maximum peak and the maximum trough response. The RMS energy simply gives us the RMS value between those 2 lines, those 2 boundary horizons for every point in the data. And finally, we've got the dominant frequency. Now this, you can see, gives us a really striking response in the map view, because the frequency is really identifying this anomaly in the northern section where we've got this thin event coming through, because it's drastically changed the frequency of the data. It's very low frequency to the southern area, but where we get that thin event coming through is much higher frequency now. So it makes the dominant frequency is very easy to spot anomalies and thin beds that are cutting into the data and becoming resolved. So we can look at this on all the different slices, so we can see how it looks on the next slice down. So slice 2, you can see it's not nearly as apparent there. As we go down to slice 3, it's again fading out and disappearing, so that by the time we get to slice 4 and slice 5, it's no longer as dominant or as apparent, and you get more variability in the response. So you can see how a single attribute varies down between each iso slice, as well as looking at what the different attributes show you on each iso slice. The final attribute is thickness, and this simply shows us the thickness of each slice. This is going to be uniform across the slices because they're all isoproportional, but you can see variation laterally along the horizon map. We've got the thinnest areas in red up the top here, which corresponds to where we've got the higher frequencies as well, interestingly, and we've got the thicker zones down towards the bottom. Any of these attributes can be exported by selecting the appropriate iso slice, the center surface, and also any of the attributes that you've calculated over it. Once exported, they will appear on your horizon in your main horizon list, and you'll get the option to display the isoproportional attribute. And you can then see it in your main 3D window. I hope this has helped you with the isoproportional slicing. Thank you.